How are you, dear engineering and scientific students? I'm very happy to have you today, and I would like to take this chance to welcome you into our wonderful online institution that called Tanzania Online Institute of Technology in square bracket Olenjolai. How are you, everybody who is watching this wonderful lecture? I would like to take this opportunity to welcome all the bachelor degree in engineering and all the bachelor degree students that pursuing in science. It means that BEng and BSc means bachelor in engineering and bachelor in science. You're warmly welcome into this wonderful session and this wonderful lecture, and I would like to take this opportunity to welcome also lecturers, tutorial assistant, instructors, and even if assistant lecturers who are teaching the beauty of higher engineering and scientific mathematics. So I'm very happy today. I have prepared a very good news just to transform your mindset from the region of ignorance to the region of knowledge, comprehension, understanding, and wisdom. So my name is Olenjolai. I thank God who have given me a gift of teaching. I have an assignment to teach you about the truth of the Word of God. I have an assignment to teach you about mathematics. I have an assignment to teach you about natural science, and I have an assignment to teach you about electronics and telecommunication engineering, computer engineering, biomedical equipment engineering, and also computer science. So I have an assignment also to teach about the beauty of computer science and etc., etc. So 5 areas of teaching that I have an assignment to teach. I thank God who have given me gift, He has given me a fresh anointing, and I'm going to use that fresh anointing to teach you by using a simple language and transform your mindset from the followers in mathematics to become leaders in mathematics. So you're warmly welcome into this wonderful lecture. We are here, we are serious, we are committed. This is the work of our heart, and we have an assignment to do it for the rest of our life. I'm not doing this wonderful business alone. I have an assistant who is my beautiful wife. Her name is Nekinyi Olenjolai or Joinais Olenjolai. So we are always together in prayer. We are always together in just teaching, in editing the videos and publishing and distributing and even marketing to the Tanzanians. I have an assignment to teach you about university mathematics, university higher engineering mathematics, and also college higher engineering mathematics, and the institution higher engineering mathematics. That's one of my area of specialization, and I love so much mathematics. I believe also you do so, but in case that you hate mathematics because you got wrong teachers or you've been taught poorly, and so you hate mathematics and possibly you lost your capacity, then I want to tell you that all my lectures will be transforming you and will be actually entertaining you and make you to enjoy and make you to master engineering mathematics modules. So this is the serious classes. I would like to ask you to have your scientific calculator, to have an exercise book, to have reference books that I will mention in this lecture. You must have your pen, you must have your pencil, you must have your ruler, and then write everything that you are going to write, that will be teaching you verbally and also will be teaching you just by writing. So let's take this opportunity to welcome you into one of our institutions that called Tanzania Online Institute of Technology. This is the wonderful institution where that we are teaching undergraduate or bachelor degree students in Tanzania by using the curriculums of different universities in Tanzania. But also remember that the field of engineering, the field of computer science is universal. The field of the Word of God is universal. So the concept that I'm going to teach you, if you are you're a student from England, you're a student from United States of America or from India, this material will be very useful to you. However, that will be focusing on using the curriculums of Tanzania's university, colleges, and institutions. You're also welcome to our official YouTube channel where that we are providing our content that called Tanzania Online Institute of Technology in square bracket Olenjolain. Olenjolai is my name, and N is the first letter of my beautiful wife that called Neking. So this is the wonderful official YouTube channel. We have 6 departments in this wonderful online institution. And one of the departments is called Departments of Higher Engineering and Scientific Mathematics. Say it, Department of Higher Engineering and the Departments of Higher Scientific Mathematics. So Departments of Higher Engineering Mathematics and Departments of Higher Scientific Mathematics. So mathematics and science combined together, but will be differentiated depending on the modules. So also, I would like to take this opportunity to tell you that we are going to teach you so many modules or courses in these departments of higher engineering and scientific mathematics. So today I'm going to teach you about the module called Engineering Mathematics. And I'm going to use the curriculum of Dar es Salaam Institute of Technology that is prepared by the Departments of Electronics and Telecommunication Engineering. And this course, it has been transformed its name from curriculum to Engineering Mathematics. And then some courses at Dar es Salaam Institute of Technology, or DIT, they are learning in Departments of Electronics and Telecommunication. We call them to be Beng24 or Beng25 Beng24 COE, Beng25 COE, Beng26 COE, Beng24 Lab Science and Technology, Beng24, Beng25 in the BEBE, Biomedical Equipment students, etc. So this is the new module. It's not new actually because it's been taught for almost more than 3 years. So it's a very interesting module. Previously it was called the calculus. Nowadays it is called Engineering Mathematics. Engineering Mathematics. Then you are welcome into these contents are prepared specifically. This is class specifically for the first and second year engineering careers, engineering and scientific careers. Students who are pursuing, who are in first year and second year in different fields of engineering, including University of Dar es Salaam, University of Dodoma, and University of Karume Institute of Technology in Zanzibar, etc. And then simply we call that this is BEng. B is abbreviations of bachelor. Eng is abbreviations of engineering. So this is bachelor in engineering. And BSc, the B standing for what? Bachelor. And CSc standing for is abbreviations of science. And then for the inactivate, we call it NTA level 7. First year and second year and third year also for the Form 60, we call it NTA level 7 according to NACTIVATE, National Council of Technical Education and Technical and Vocational Education. So then this is lecture 0, the first lecture. So the first lecture is titled as what? General Introduction. I'm going to teach about the general introductions of engineering mathematics. General introductions of engineering mathematics. Then this just dedicate this session to Beng24 Beng24 COE, Beng24 Beng24 BEBE, BEBE or BEE, Biomedical Equipment, and also Beng in this in all of these 5 courses or 4 courses, Beng25, Beng. I dedicate this also to Beng26. And also dedicate this to all Beng in these departments 27, etc. So this is my dedication for the specific course. Are we together? So is it clear? Remember that our classes are very interactive. So we'll be giving you a chance to ask a question. You may ask a question in the chat or in the comment section, and we'll try our level best to answer your questions. We have also our WhatsApp group, and that will be sharing to you, that we ask you to it's called, our WhatsApp group is called the Tanzania Institute of Technology or Tanzania Institute of Tech. Okay, so that is our WhatsApp groups. We'll be sharing to you about how you can join, and I'll share a link to you so that you can join and interact together. So you can share the PDF and you can share the solutions of your homework through the WhatsApp, because we are using YouTube currently now as the platform of teaching, and also you're using WhatsApp as another additional or supplementary platform to the YouTube, because you cannot attach maybe the PDF files or the Word file or maybe just the cam scanner files into the comments sections of YouTube, but you can attach it into WhatsApp. That's why we've created a special group for Tanzania on our Institute of Technology, Tanzania Online Institute of Technology. Just we call it in short. We have a WhatsApp group. We'll be interacting there, but let us interact in the comment section. Again, we'd like us to ask you, if you're first time, please register yourself. It's free. We provide our contents just for sometimes just free, and then we ask you that to click the buttons of subscribe so that you'll be receiving notification as long as we publish a new video for you. Are we together? Are you ready to learn general introductions of engineering mathematics? The answer is yes. Then at the end of this session, of this lecture, I will ask you, do you understand me? Then tell me in the comment section, yes sir, I understand you. No sir, I don't understand you. And be faithful. Are we together? But because this is, my teaching is, the foundation of my teaching is God himself, I always trust in prayer, regardless of your faith, regardless of your domination, regardless of your religion. Before we start our lecture, I would like to ask you just to spend at least 1 minute to welcome God and to pray before God. Let us pray. Our Father who is in heaven, we come before your presence and say thank you for this opportunity. Thank you because you're wonderful and grateful. We repent for all my sin, for all our sins, all our transgression, all our iniquities, and all our rebellions that we have committed before you. Father, forgive us and wash us by your precious blood of Jesus Christ. And we welcome you right now, Father, to teach us the beauty of engineering mathematics to the first and second year, NTA level 7, BNG24, BNG25, BNG26, BNG27, and BNG28, BNG29, BNG30, in the name of Jesus Christ. Welcome, Holy Spirit, to teach me how to teach your students, and welcome also to teach online students, and let them be serious and take serious these lectures as how they take serious the physical teaching. Father, I thank you because you are faithful and you are always with me, and you are here and you are ready to teach us. In the name of Jesus Christ, amen. Amen. Glory to God. Let us start our session. So in this introduction, general introductions of what of engineering mathematics, let me start talk about curriculum. In secondary education, the Tanzania Institute of Education and other institutions in different countries prepare something or guidelines that call the syllabus. But in college institutions and universities, they do prepare a document that the guidelines, it means that the visions or the directions or the instruction in very formal, organized form, and it's called the curriculum. So we are going to refer the curriculum of engineering mathematics, and that curriculum is prepared by Dar es Salaam Institute of Technology and the departments of electronics and telecommunication engineering and departments of computer studies. Okay, so that's very important. So the curriculum that we are going to use is curriculum of 40, curriculum of department of electronics, departments of electronics, and the telecommunication engineering, and also in collaboration with departments of 40, departments of computer studies, departments of lab tech and science, and also departments of 40 of electrical engineering, special for biomedical equipment, electrical engineering. So that's the curriculum that you are going to refer. So then we say that according to the curriculum, so these are the information which have been written in the curriculum and I've extracted from that curriculum. So these are not my own information. The only section of topics that I'm going to teach you or to formulate the topics is my own section. But all about sub-enabling outcomes, the credits, sub-enabling outcomes, we'll be discussing about the prerequisite, we'll be discussing about method of teaching, and then reference books. Those are written in the curriculum. And any lecturer or assistant lecturer who will be teaching you about engineering mathematics must share or introduce to you about this information in the first lecture, because you will understand about the coverage of the module or what it has been said for you to learn as a serious student. Okay? So let us start with very important information. Number one, we call it the code of the module. What the code of the module? Code of the module. This is very important. So the code of the module is called the GSU 07 then 312. This is the code. G standing for general. S is standing for studies. U standing for what? Undergraduate. 07 standing for NTA level 7. Then 3 it has its meaning, but 1 standing for the first semester and 2 standing for the number of the module in the curriculum. So GSU simply undergraduate modules in departments of general studies that teaches higher engineering and scientific mathematics, NTA level 7, first semester, right? That's very important. This course is usual, very important, and you have to know at the serious students, if especially you're studying at DIT in those departments that I've mentioned. Then the number of credits. What are the credits? The number of credits for these modules. How many credits that this module has? So according to the DIT curriculum, or according to the curriculum, then this module has grade, number of grades number 9. Then now let us discuss about very important section that is called the sub-enabling outcomes. Sub-enabling outcomes correspond to specific objective in case of the ordinary secondary education syllabus or syllabus for advanced secondary education. So now we are going to discuss about 30 sub-enabling outcomes. Say sub-enabling outcome. Say sub-enabling. So sub-enabling outcome, these are the objective of engineering mathematics from the curriculum. So sub-enabling outcomes of engineering, sub-enabling outcome of engineering mathematics. These are the sub-enabling outcomes of engineering mathematics. There are 7 sub-enabling outcomes, 8 sub-enabling outcomes for this module, and they're supposed to know. So remember that I'm quoting from the curriculum. The first sub-enabling in the curriculum has been written as section 1, section 4.1.2. The first sub-enabling outcome, a student must be able to apply mathematical knowledge. Students must be able to apply. Please write these sub-enabling outcomes because these are the ones give you the guidelines, give you the knowledge, give you the overview or about the module. So even be spending your time to read yourself, then you'll be having the guidelines. You know what should you cover. So apply mathematical knowledge. Apply mathematical knowledge to determine. Apply mathematical knowledge to determine limits and the continuities. Limits and continuities of functions. Functions of single and the several variables. This is the first sub-enabling outcome. Please pause the video and write this first sub-enabling outcome immediately. Once you're finished right, then I would like to ask you to pay attention, listen, and watch. Let us read. 1, 2, 3. Let us read together. The first sub-enabling outcome. A student must be able to apply mathematical knowledge. So this is just, I'm trying to underline the keywords. Mathematics, you should be able to apply mathematical knowledge to determine what? Limits. Determine limits and the continuities of the function of single variable and the several variable. So a student at the end of the learning the modules of engineering mathematics, you must be able to apply the mathematical knowledge that you have been learning in advanced secondary education and also in ordinary diploma, and also you should apply the mathematical knowledge that you've learned in calculus, spatial differentiation, in order to be able to determine limits of the function, okay, of the functions of the single and the several variable. These first sub-enabling outcomes create the first topic that called the theory of the limit. So when you talk about the limits and continuities of the function of the single variable, remember that the function of single variable, just to remind you, is for instance that y is equal to x squared plus 4. So this is the function of single variable. But the functions of the several variable is, let's say y is equal to x squared plus, let's say, sine of y, and plus what, and let's say that divided by, let's say that log of what? Log of xy. So this is the function of several variables. Why? Because we have a single dependent variable, but we have two independent variables, x and y. So this is the function of two variables, and this is the functions of single variable. Why? Because you have only one independent variable. This is the independent variable, independent variable, independent variable. This is dependent variable and dependent variable. And in case that you want to learn more, stay connected and be a serious student of Tanzania Online Institute of Education. Then you will enjoy this course now and forever. So that is the first sub-enabling outcome. Then according to the curriculum, so it's written as 3, section 6, 3.3.34. The second sub-enabling outcome that a student must achieve, a serious student must achieve who would like to be and apply mathematics in engineering. A student should be able to employ time and frequency. A student should be able to employ time and frequency. Domain, time and frequency, domain. So actually, you find that from the curriculum, these sub-enabling outcomes have been presented in form of the table. Okay, in form of the table. Employ time and frequency domain to analyze. To do what? To analyze. Employ time and frequency domain to analyze continuous and discrete time. And the discrete time signal. Discrete time signals. So employ, so we have to teach the students on how to employ time. So pause the video and write that second sub-enabling outcome. If you finished, then let us read. I'll be using different teaching aids and different teaching techniques to make sure that you understand the material that I'm going to teach you while I'm teaching. And I want to promise you that you will never struggle during your own revisions or preparation for examination, because you've understood. You'll be just reviewing and reminding yourself everything about engineering mathematics. Are we together? In case you have a question, don't hesitate to ask in the comment section. So let us read now. Remember that one of the techniques I will teach you to read the sentence in your minds at least twice or three, and then you'll find that that sentence will be written in your mind, in your subconscious mind, or in your memory. A student must be able to employ what? Time. I have to teach you to be able to employ time domain, and frequency domain. This is transformation. Time domain and frequency domain. So we can have time domain and Laplace domain, or S domain. We can have time domains and Z transform domain, or det domain. So time domain and frequency domain. So frequency domains is mostly used in digital to analyze what. So it's because remember that this syllabus or curriculum has been prepared specifically for electronics and telecommunication engineering students, computer studies students, electrical engineering, etc. To analyze continuous, which we call them analog time signals, and to analyze discrete or digital time signal. So a student must be able to employ time domain and frequency domain to analyze continuous and discrete time signals, or to analyze analog and digital signals that you've been learning in different modules, such as signal processing. You've been learning about analog signals in different modules in analog communication laboratory. You've been learning about digital signals in digital electronics, etc. So here we have to teach you mathematical techniques to analyze, doing analysis of analysis of analog and digital signal. Did you understand the second sub-enabling outcome? Stay connected. I will teach you the secret there, because this is my area of specialization. Then the second sub-enabling outcome is just referred as section 4.1.3. Then a student and I as a teacher have to teach you. I have to teach you to be able, or to master, I have to be able to use mathematical knowledge. Mathematical knowledge. Mathematical knowledge to derive. Use mathematical knowledge to derive Fourier series. Fourier series. Remember that this is formulating the first topic, and this is not oftenly taught because this is more digital mathematicians. So in normal classes, the most mathematicians or mathematics teachers, because they don't have a background of analog and digital signals, they skip this sub-enabling outcome, according to my experience and according to my observation of 3 years. So you should be able to use mathematical knowledge to derive Fourier series of various function. Fourier series of various function. What are those functions? First of all, polynomial function. You should be able to derive Fourier series of trigonometrical function. Should be able to derive Fourier series of exponential function. Please pause the video and write, and then thank you for writing. Now let us reinforce this steady sub-enabling outcome. A student should be able, at the end of learning engineering mathematics, I, the teacher, have to help you and to teach you in such a way that you'll be able to use mathematical knowledge. Which mathematical knowledge are you going to use? Stay connected, I will teach you. To derive Fourier series of various mathematical functions. And I will teach you. I gave you example of this function: polynomial function, exponential function, and trigonometrical function. Those are the common functions that we have in Fourier series. So this one will develop the second common topic that called the Fourier series. Say Fourier series. Say Fourier series. Say Fourier series. So this will be formulating the second topic. Then next, section 4.23. Section 4.23. Let us now move into the fourth sub-enabling outcome. Do you understand? Please let me know in the comment section, please, and in the chat, just you understand what I'm teaching you as a general introduction. Say general introduction of engineering mathematics. So section 4.23. A student, I have to teach you. A teacher or a lecturer has to teach his students to be able to apply Laplace transform. Very interesting, my favorite topic. Laplace transform. Say Laplace transform. Again, say Laplace transform. Laplace transform of various function. Of various function. Laplace transforms of various function to solve engineering related problem. To solve engineering related problems. To solve related engineering problems. Pause the video and write the first sub-enabling outcome. Thank you. Let us reinforce understanding. I, Olenjolai, I have to teach you in such a way that you'll be able to apply Laplace transform of various functions to solve different electronics engineering problems, to solve different telecommunication engineering problems. I have to teach you how to apply Laplace transform of various functions to solve various computer engineering problems. Also, I have to teach you how to apply Laplace transform of various functions to solve different biomedical equipment engineering problems, real-life problems. This there, say the first sub-enabling outcome, and this first sub-enabling outcome will formulate the third topic that called the Laplace transform. Say Laplace transform. Say Laplace transform. So the first keyword here is called the Laplace transform. And then once you learn Laplace transform, you should be able to apply to solve what? Should be able to solve different engineering related problems. Is it clear? Did you understand? So here we'll be having the third topic that's called the Laplace transform. Do you understand? Then let us move into the fifth sub-enabling outcome. This in curriculum is labeled as 4.32. And this sub-enabling outcome is presented as solve engineering. Solve engineering related problems. Solve engineering related problems. Related problems using calculus. Using calculus of complex function. Using calculus of complex functions. Using calculus of complex functions. So this is our fifth sub-enabling outcome. I would like to ask you that to pause or maybe write it quickly. The fifth sub-enabling outcome from the curriculum of departments of electronics, telecommunication, engineering, computer studies, lab technology, and science, electrical engineering departments, and even civil engineering, the new courses, they used to study this new module that's called engineering mathematics. Are we together? Do you enjoy the general introductions of engineering mathematics? If the answer is yes, let me know in the comment section. Do you understand me? Then let us read the fifth sub-enabling outcome. Solve engineering related problems using calculus of complex function. Say complex function. Say complex function. Say complex function. In mathematics, we have complex function, or we have which is formed by complex variables, and also we have normal. Just we call them non-complex or just normal function that formed by normal variables, normal single and the multivariable, normal single and the several variables. So the complexity function is actual the advancement of the topic that we taught in advanced physics from 6C in the topic that's called the complex number. So we taught you about complex number. We did not teach you about complex function. So in this case, we taught you about complex number, about the real part of the number, of the complex number, and imaginary part of the complex number. In case of the complex function, the real part will be the function, and the imaginary part will be the function. And in most cases, you'll find that you might have a single variable complex variable. You can have a single complex variable and several complex variable. So it's very interesting. So this one will be formulating our first topic that's called the complex function. Are we together? So it means that I have to teach you how to solve different electronics, telecommunication, computer engineering, biomedical, engineering related problems by using calculus of what? Of complex function. So you say that calculus of complex function, we have differentiation of complex function, we have also integrations of the complex function. Are we together? And they are very interesting principles and the laws. Principles and laws that are applied in complex function. And one is called the Leibniz. Leibniz, is it Leibniz? Yes, one is called something Leibniz and etc. Okay, then, is it clear? Is the fifth sub-enabling outcome clear? Then now let us move into sixth sub-enabling outcome, which is numbered as 4.5.35 in the curriculum. And this one also established another important topic that I have to teach you to apply Fourier integral. Fourier, remember that this is Fourier integral. Fourier integrals. I have to teach you to apply Fourier integrals of various functions, not of the single function or single type function, of various function, to solve engineering related problems. This is the sixth sub-enabling outcome. Please copy it in your exercise book and then let me introduce to you. Thank you. Let us reinforce the understanding and write this sixth sub-enabling outcome into our mind. I have to teach you to be able to apply Fourier integrals of various functions, which we have never taught you in advanced secondary education or in ordinary diploma, to solve engineering related problems. Say Fourier integral. Say Fourier integral. So the key word here is Fourier integrals. Not normal integrals, Fourier integrals. Remember that in these sub-enabling outcomes, we'll teach about Fourier series. We have Fourier series, and Fourier series will be look like Maclaurin series. Will be look like Taylor series that you've learned in differentiation. Will be look like binomial series that you'll be learning in algebra. Okay? So this is the series. Means we'll be having first term, second term, third term, fourth term, etc., etc. And depends whether we have it's a finite series or infinite series. So then, this is the sixth sub-enabling outcome. So Fourier integrals of various functions to solve. So do you see that? The main objective, the main intentions of engineering mathematics is to teach you to solve different engineering problems by using mathematical knowledge. So Fourier integrals of various functions to solve engineering. To solve what? Engineering. So engineering mathematics prepare you to be a real theoretical simulation programmer and a practical engineer. That is I wish you to be. Then the seventh sub-enabling outcome is just numbered as 4.15 in the curriculum. And this sub-enabling outcomes is known as apply. Apply what? Apply mathematical. I have to teach you on how you can apply mathematical knowledge. Mathematical knowledge. Mathematical knowledge. To do what? To derive. To derive. Again, to derive what? The Fourier transform. The Fourier transform. Derive the Fourier transform. Derive the Fourier transform of various function. Various function satisfying Dirichlet. Satisfying the Dirichlet conditions. Finds the Dirichlet condition. This is the seventh sub-enabling outcome of the modular course called Engineering Mathematics for engineers and the scientists and the bachelor level or degree level or undergraduate level of Tanzania, of Africa, of America, of Europe, of Asia, continents, of Australia. Then, please write the seventh sub-enabling outcome. Thank you for writing. Let us reinforce understanding and write in our subconscious mind so that we have to remember every time. have to teach you to be able to apply mathematical knowledge. Say mathematical knowledge. Say mathematical knowledge. So Olenjolai is going to teach me on how to apply mathematical knowledge, on how to apply Laplace transform and to solve related engineering problems, and will be teaching you in a very high quality compared to your class lecturers, assistant lecturers, and tutorial assistant. Why? Because we'll be using different material, we'll be referring different textbook, we'll be preparing our lecture by using the DAT notes, and also we'll be solving different questions of test 1, test 2, and makeup testing, final examination or end of semester examination, and supplementary examination. I'll be finding questions from those past papers, and I'll be teach you how to solve them in order to make sure that you understand engineering mathematics, but also you score grade A with a very high pass mark of not less than 90 in your all examination, in test 1, test 2, and also in your end of semester examination. So in case you want to do well, you have to transform yourself from the grade F to grade A, then Tanzania Online Institute of Education is a correct answer, and it's a correct place for you to be transformed. I have a testimony of the students that have been scoring F, and I taught them and transformed them until they have been scoring grade just grade A. And you may see the testimony, for instance, Mr. Muhidini, who has been testifying as just that he has been scoring F, and then once he met me and I taught him, he has been attending my classes day and night, every time, doing assignments, just asking questions, and then he has been scoring grade A for all 3 modules among the 4 modules. Are we together? So I'll be teaching about how to use mathematical knowledge to derive. In engineering mathematics, we are going to derive. To derive what? Fourier transform. Say Fourier transform. Say Fourier transform of various functions. Fourier transform of polynomial function. Fourier transform of exponential function. Fourier transform of trigonometrical function. Of various functions satisfying the Dirichlet's conditions. I will teach about these Dirichlet's conditions. So I will teach. So the 6 sub-enabling outcome, Fourier integrals, and Fourier transform will form one topic. Then we have section what? 4.3. 4.36. 4.36. Or this one is another, because Fourier integrals, you are using another technique, and Fourier transform plus inverse of Fourier transform, or Fourier transform, also formulating another topic. So we'll be formulating another topic. Then the last sub-enabling outcome, the last but not least, I have to teach you to be able to solve different engineering related problems. Different engineering related problems. Related problems by using vector field theory. Vector field theory. Simply, this we call it vector calculus, or vector in calculus. Because remember, we have scalar quantity and vector quantity. So vector quantity is also need applications, intensive application of calculus, and the number of theorems there, including Green's theorem. But also in vector calculus, we teach about double integrals and triple integrals and line integrals that we've been learning in electrostatic during your advanced secondary education studies. So dear students, these are the 8 sub-enabling outcomes of engineering mathematics. So 8 sub-enabling outcomes usual can form 8 topics, but I told you that this one is always skipped, or it's not taught. Maybe I will teach you because it's very applicable in electronics engineering, telecommunication engineering, computer engineering, and also biomedical equipment engineering, and also even mechatronics. These modules also might be helpful to the students who are pursuing mechatronics engineering, mechanical engineering, chemical engineering, industrial engineering, maybe bachelor in science, bachelor in what? Applied science, bachelor in laboratory science, bachelor in what? Bachelor in biotechnology, etc., etc. So, dear students, these are the 8 sub-enabling outcomes. Let us just see, reread them for the last time, and then we move into the next section. The first sub-enabling outcome, let us read. You should be able to apply mathematical knowledge to determine limits and continuities of the function of the single and several variables. We'll be formulating one topic here. Then we'll be able to employ time and frequency domain to analyze continuous and discrete time signals. You as a student at the end of engineering mathematics should be able to use mathematical knowledge to derive Fourier series of the various functions. Then you should be able to apply Laplace transform of various functions to solve engineering related problems. Then you should be able to solve engineering related problems using calculus of complex functions. Then you should be able to apply Fourier integrals of various functions to solve engineering related problems. Then you should be able to apply mathematical knowledge to derive the Fourier transforms of various functions satisfy the Dirichlet's conditions. And the last but not least, you should be able, so let us reinforce our understanding, you should be able to solve engineering related problems in your field or in your course, engineering related problems, using what? Vector field theory. Do you understand the 8 sub-enabling outcomes of engineering mathematics? Then I want to tell you that if you learn engineering mathematics by following these 8 sub-enabling outcomes and satisfying every outcome, every sub-enabling outcome, I want to tell you that you will be a very wonderful and competent electronics engineering students, telecommunication engineering students, computer engineering students, mechatronics engineering students, biomedical equipment engineering students, civil engineering students, and even mechanical engineering students in some cases. And you'll be able to apply mathematics in different modules or courses that we call them core courses. This is fundamental course, fundamental compulsory course, or fundamental compulsory module. But you'll have your own core module offered by your departments depending on your career. Are we together? So before I present to you about before I present to you about the prerequisite module, yes, prerequisite module. So now prerequisite module. Say prerequisite. Prerequisite module. Prerequisite what? Module. So prerequisite module, this one is called the none. Prerequisite module is none. The modules of engineering mathematics does not depend or does not need the students to have a prior knowledge of the maybe first year or ordinary diploma modules. That's the meaning that prerequisite, the prior module that you should learn before you learn engineering mathematics. But engineering mathematics will be the prerequisite module for advanced engineering mathematics that will teach you in second semester. This is the module for the first semester, and advanced engineering mathematics we teach at DIT as the second semester module. Are we together? So then now, ladies and gentlemen, let me mention the 8 or the chapters. Chapters of what? Of engineering mathematics. Based on this sub-enabling outcome, then we can formulate 8 chapters from the 8 sub-enabling outcomes that we are supposed to cover. The first topic is limit and continuity function. Limit and continuity function together we call it a theory of limits. Theory of limits. So chapter 1. So the first chapter, please, are you together with me? Chapter 1 is called the theory of limits. So the main subtopics are limits and the continued limits of single variable. We usually teach you limits of single variable, but according to the sub-enabling outcomes, we have to teach you also limits of several variable function. We'll teach you limits of the single variable function. Usually that's what is being taught at the IT. Why? Because they don't refine, they don't follow what it has been stated. So we violate sometimes, and forgive us for violating. So that's the first topic. Then the second topic, this is called the chapter 2. We find it from the second sub-enabling outcome, to employ time and frequency domain to analyze continuous and discrete time signal. So it's called this, so this topic, we call it the time and the frequency, time and frequency domain. Time and frequency domain. When you talk about domain, we don't mean about domain and range of the function. Times and frequency domain means the discrete signal or continuous signal might be presented as a function of time. Frequency domain means that the discrete signal, especially the digital signal, discrete time signal, is represented as a function of frequency. So you have Fourier transform, we apply in signal processing, and we apply this mostly cases in just converting analog signal, digital signal, and converting a digital signal to analog signal, designing filters, etc., etc. So this is chapter 2. Chapter 4, chapter 3. So chapter 3 is called what? Is formulated from this said sub-enabling outcome. Use mathematical knowledge to derive Fourier series. So it's called this simply Fourier series. Fourier series. This is the third chapter. This is the fourth chapter. According to this list, this is the third chapter. However, that it will be the what? It will be it might be any of the chapter. Then chapter. So for Fourier what series will be teaching you how to use calculus and generate the series. Chapter 4, we just find it in what? In the fourth sub-enabling outcome. That called what? Laplace transform. Laplace transform. Laplace transform. Laplace transform. So once we cover the topic of the theory of limits, we usually teach you Laplace transform before teaching you about Fourier series. Then we have what? Chapter what, dear students? Chapter 5. So chapter 5 is called the complex calculus of complex function. Calculus of complex functions. Calculus of complex function. So you have calculus of the complex, you have differentiation of complex function and the integrations of complex function. Chapter what? Chapter 6. So chapter 6. Chapter 6 we find in the sixth sub-enabling outcome. Apply Fourier integrals. Fourier integrals. So apply Fourier integrals. So Fourier integrals. We have general Fourier integrals function, and also we have cosine Fourier integral function and sine Fourier integral function. We'll teach you about that. Remember that we just taught you the concept of limits a little bit in calculus, in differentiation. We have never taught you about time and frequency domain in A level or ordinary diploma education. We have never taught you about Fourier series in A level because I'm teaching advanced secondary mathematics or advanced pure mathematics. And we have never taught you about Laplace transform in advanced pure mathematics, and also in different modules of engineering and science in ordinary diploma. We have never taught you about calculus of the complex function in advanced secondary education and in ordinary diploma. We have never taught you about Fourier integrals in advanced secondary education and also in ordinary diploma, NTA level 4 to NTA level 6. So these topics are new. And I want to tell you that I have been teaching this topic for more than 10 years before I teach you. So I thank God who have given me first of all, the heart of loving mathematics, and secondly, teaching consistently. So I have experience on engineering mathematics. However, I don't know everything. I know a small portion, but I have an assignment to teach others and transform followers in engineering mathematics to become leaders in engineering mathematics. So the next is chapter 7. Chapter 7, we find it in sub-enabling number 7, which is called the Fourier transform. So it's called the Fourier transform. So you might note that Fourier transform. You might note that the heart of engineering mathematics is Fourier, because you have Fourier series, we have the Fourier integrals, we have the Fourier transform. That's the heart of engineering mathematics. Then chapter 8, the last one. Chapter 8, the last topic is called what? Vector theory. Vector field theory. Vector field theory. In calculus, field what? Theory. In calculus, this one is called what? Is called the vector calculus in some of the books. Vector calculus. Vector calculus. So these are the 8 topics that you may develop from 8 given sub-enabling outcomes that you must learn and master for the rest of your life. Do you understand? So these are the 80 topics. Let us just recall them: the theory of limits, the frequency and time domain, for Fourier series, Laplace transform, calculus of complex function, Fourier integrals, Fourier transforms, vector field theory, or vector calculus. Are we together? Interesting. So then, now, the next section now, we are going to discuss. I believe that you have understood. In case you not understand, please ask questions in the comment section. And if it's your first time, you are warmly welcome. This is Olenjolai from Tanzania, who is teaching about engineering mathematics. And remember to click the buttons of subscribe for you to be a serious student in our online training. Again, another important section is learning context. So others I'll be just reading because of the time. Learning context. This module, according to the curriculum, this module will be conducted through lectures, tutorials, assignments, and group discussion. Learning what? Context. Learning. How do you learn? How do you learn this module? So how do you learn this module? Context. Context. Learning context. So this module, say learning context. So this module of engineering, this module of what? Of engineering mathematics will be conducted through what? Through number 1, lectures, just like lecture 0, lecture 1. Number 2, number 2 is tutorials. Number 3, through tutorials means solving question, through assignment, class assignment. And number 4, through what? Group discussion. Group discussion. So you'll be formulating your WhatsApp group discussion. So these are the 4 methods that you may use to learn and master the modules of engineering mathematics. Then learning materials, you may learn through blackboard, white chalk, anti-dusty, whiteboard, marker pens, multimedia, presentation, interactive simulation. Then the second section, before the last section, let me present to you, dear student, the integrated method of assessment. How do class lecturers, how your lecturers will assess you? So this is actually called the integrated. Say integrated. Say integrated. Integrated method. So integrated method of assessment. Integrated method of assessment. Integrated method of assessment. Assessment of engineering mathematics. This module will be assessed in two ways. Continuous assessment, which in short we call TCA, and the end of semester examination. So number one will be assessed in continuous assessment, continuous assessment, continuous assessment, and continuous assessment. The weight of continuous assessment, or CA, in short it's CA, is 60%. 60%. 60% out of 100. Then, so it means that this section will cover or will reward you 60 marks. So 60 marks. So the minimum pass mark. The minimum pass mark. The minimum pass mark of CA is 24% or 24 marks. If you score 23 marks, then you have failed the continuous assessment and you are supposed to repeat the module in the next academic year. So CA is 60% or 60 marks. Minimum pass mark of CA is 24. And what will be the components of CA? You'll be given test 1, you'll be given test 2, you'll be given assignment, individual assignment, be given individual assignment, and also you'll be given group assignment. Group assignment. So test 1 might carry 20 marks. Test 2 might carry 20 marks. Remain what? 20 marks. Individual assignment might carry 10 marks. And group assignment might carry 10 marks. Or 10%. So total makes what? 60. Then the second assessment mode is called the second assessment mode is called what? Is called the end of semester examination. End of semester examination. End of semester what? Examination. So number 2 mode of assessment is called the end of semester. Of semester examination. In other words, at DIT, this is called the examination. Examination. So this in DIT is called in short FE, which is final exam. In some of the universities it's called the university exam or UE. So this one has a weight of 40 marks. You'll be given a written examination with a number of questions. They'll be asked to answer all the given questions. All the given OT, all the given questions. Right? So end of semester examination has a weight of 40 marks. In that exam, so you'll be given a written exam. You'll be given 3 hours. Remember that for the test is 1 hour. 3 hours long exam. Long exam with 2 sections, section A and section B. With 2 sections. So you are going to have section A, and according to the DIT format, section A will reward you 10 marks. 10 marks. And then section B and you have to answer all the questions. And mostly 10 questions of one, each of them is 1 mark. And then section B, so you'll be rewarded 30 marks. And for this case, mostly you might be given 6 questions. Each question has a weight of 7.5. So you're supposed to answer. So here, in most cases, you're supposed to answer 5 or 10 questions. So if I'll be given 5 questions, it means each question will have 2 marks. If you'll be given 10 questions, each question will have 1 mark. We'll be solving. Don't worry. We'll be solving a number of final exams or end of semester examination of the previous year to prepare you and to give you the clear mind. But also for the section B, this is multiple choice. It means that you have to choose. You have to answer, for this one, you have to answer 4 questions. 4 questions. 4 questions out of 6 questions. Out of 46 questions. Sometimes you might find that you may be asked to answer 3 questions out of 5 questions. You should not cram. So remember that each question for section B carries, it means that each question, for this case, each question carry what? Carry 7.5 marks. If you'll be asked to choose or to choose 3 questions, then each question will carry what? 10 marks, because total should be certain. Are we together? Do you understand? So it means this section, I've been talking about what? Examination. How the institutions, university or college test your level of understanding. You'll be tested continuously for 15 weeks, and here will be tested for only 3 hours. So this is just the continuous assessment. This is accessed for 15 weeks. But this one, the end of semester examination, will be assessed only for 3 hours in a single day. Okay? 3 hours. Do you understand? Do you enjoy the general introductions of engineering mathematics? Do you get very important academic information? Do you get very essential and crucial information that you have been missing during your studies at university or institution or college level? If the answer is yes, then give all the glory to Almighty God, who have taught me and revealed your problems and learning problems or your challenges in learning and mastering engineering mathematics at university level in my heart, and then now I came with a response. Is it clear? Please write this for your present and future reference. Now, ladies and gentlemen, I would like to present to you or to teach you the last section of general introductions of engineering mathematics that is called the reference materials, reference books. What are the recommended reference book for you to have as soft copy or hard copy, mostly soft copy, in order to learn and master all the 8 sub-enabling outcomes and all the 8 mentioned topics? What are the reference books that you may use? What are the reference books that have been used just to formulate the 8 sub-enabling outcomes of engineering mathematics? If that is your question, then stay connected. I'm going to answer and give you a list of reference books for engineering mathematics. Do you love engineering mathematics? Ask your neighbor, my neighbor. Tell me please, do you like engineering mathematics? His or her answer might be yes or no. But if it is yes, keep it up. If it's no, welcome to Tanzania Online Institute of Education, because we'll teach you complex concept by using a very simple engineering language, so that you may start liking and you may start like engineering mathematics from now onwards for the rest of your life. Okay? If it's your first time, you're warmly welcome. This is Olenjolai. speaking from Tanzania, proclaiming about the knowledge of engineering mathematics into Tanzania by using Tanzanian curriculum. But the engineering mathematics is universal, worldwide. So you're warmly welcome. If you want to be a serious student in our official YouTube channel, please click the buttons of subscribe. First of all, search our official online institution that's called Tanzania Institute of Education, Institute of Technology, in square bracket OLENJOLAIM. And then once you are there, then number one, we ask you to register by clicking the buttons of subscribe, and then review different playlists and different videos and different actual organize and collections of the videos, so that you may learn and may find the specific, your specific needs to feed your mind now and forever. But remember to share the links of this video to other students so that they may learn engineering mathematics anywhere at any time. Great. So now let us discuss, let me present to you about reference books. So because you may learn this topic, these modules by using journals, but journals will be complicated. So simply, in the curriculums, they have written references. But because these references, I would say that references books, because all of them are books that you may access them on online as a soft copy, and you may purchase at the hard copy because you are not limited. So reference books of engineering mathematics. So these reference books have been written by following the IEEE, or the Institute of Electrical and Electronics Engineering format. So when you want to search these books online, you just see, you are supposed to just to copy what I'm going to give you, or I'm going to write on the blackboard, so that you may find the accurate reference book. If you ignore part of it, you will find some other material. The first reference book, according to IEEE format, is called Dyke. So Dyke is the name of mathematicians who has written that book. Dyke P.G is the name of the author. And then this book has been published in 2001. And the name of this book is called An Introduction to Laplace. An introduction to Laplace transform. An introduction of Laplace transform and the Fourier series. Slash Springer. These are the publisher. Separating. Okay, right. First, the first reference book. Thank you. Let us reinforce understanding. Dyke P.G 2001. An Introduction to Laplace Transform and Fourier Series. So this is the name of the author, and this book has been written in 2001. And the name of the book is called An Introduction to Laplace Transform and Fourier Series. If you have this book, you'll be able to learn this first chapter that's called the Laplace Transform, and the third chapter that's called the Fourier Series. The second reference book. The second reference book is called the Bed-John. So Bed-J, it means Bed-John, or John Bed. This is the famous for ordinary diploma students. John Bed in 2014 wrote a mathematics book that's called the Higher, just like departments of higher engineering mathematics. Higher. Lift Jesus higher, higher. Oh, lift Jesus high. Lower. Step devil lower. Engineering. So higher engineering mathematics. So higher engineering mathematics. With this reference book, you'll learn different topics that we have presented. And then the publisher is Routledge Tylers. Routledge Tylers and Francis Group. And Francis Group. Francis Group. 7th edition. Means there is the first edition and the second edition to the 7th edition. Write it. The second reference book. Stop writing. Let us reinforce and write in our mind. The name of the author is Bed John or John Bed. This is the famous. He wrote also another book that's called Basic Engineering Mathematics for ordinary diploma students. And this book has been written 2014. The name of the book, read it, Higher Engineering Mathematics. It's just like our departments. Higher Engineering Mathematics. Higher Engineering Mathematics. And then Routledge, Tylers, and Francis Group. These are the name. The two. It means that the name of the publisher. And 7 editions. This is the number of editions. It is the 7th edition. Then the same reference book is called the Kaplan. We've been given from the curriculum, we've been given 9 reference books. It's called the Kaplan. W 2003. This book has been written in 2003. Advanced, it's called the Advanced Calculus. Advanced what? Calculus. Advanced Calculus. Advanced Calculus. The name of the publisher is Addison Wesley. Addison Wesley. Higher Engineering Mathematics. Higher Engineering Mathematics. So the category of this book is Higher Engineering Mathematics. Higher Engineering Mathematics. Then edition. This is 5th edition. 5th edition. So this is the said reference book. Write it. Thank you. Let us reinforce understanding. Kaplan W. This is the name of the author of the book. This book has been written in 2003. Its name is called Advanced Calculus. Addison Wesley. Higher Engineering Mathematics. This is still the name. Higher Addison Wesley. Higher Engineering Mathematics. And then there is a 1st edition of this book to the 5th edition. So you have to refer 5th edition. Once you go online onto Google, Firefox or Google Chromes, then you just write the name according to what I wrote on the blackboard. Don't change. The 1st reference book. The 1st reference book of engineering mathematics is called the Crazy E. Crazy E 2006. The name of the book is called Advanced Engineering. Advanced Engineering. Advanced Engineering Mathematics. Advanced Engineering Mathematics. The name of publisher is Wesley or Wesley and 8th edition. So there is 1st edition to 8th edition. 8th edition. So the book is called Advanced Engineering Mathematics. It has some key concepts that help you to master engineering mathematics. Stop writing. Let us reinforce understanding. Friedrich E. It's the name of the author. He wrote this book where? When? In the year 2006. The name of the book is called what? Advanced Engineering Mathematics. Name of publisher, Wesley. Edition, 8th edition. 8th edition. Do you understand reference books of engineering mathematics? Do you accept? Are you transformed? Do you get good news? Please let me know in the comment section below. Then the next book, number 5. The next book is called the Ramana. Ramana. Ramana BV. Ramana BV. The year of publishing is 2007. The name of the book is called the Higher Engineering Mathematics. Higher Engineering Mathematics. And the publisher are Tata Macro. Tata Macro here. Write the 5th reference book, and after that, let us reinforce. Ramana B.V. Name of the author. This book has been written in the year 2007. The name of the book is called Higher Engineering Mathematics. Higher Engineering Mathematics. Name of publisher, Tata Macro Hill. That is reference book number 6. Number 5. Number 6. It's called the Smith R.T. and the R.B. Minton 2002. The name of the book is called the Multivariable Calculus. Multivariable Calculus. The name of the publisher is McGraw-Hill. McGraw-Hill. This is the 6th reference book of engineering mathematics. Stop writing. It has reinforced. Smith R.T. name of the first author. R.B. Minton, name of the second author. This book has been written and published in 2002. It has been used efficiently to teach engineering mathematics since 2002. The name of the book is called the Multivariable Calculus, McGraw-Hill. It's the name of the author. Then, ladies and gentlemen, let me mention the number 7 and last reference book. If you have all of this reference book, then you have a very good and wonderful library. So the last book, but not last, it's not listing. It's not that it's least important, but just last in presenting. Is Stroud KA. I used this book during my my studies in bachelor degree in electronics and telecommunication engineering. I used efficiently this book, and it helped me a lot to understand different concepts. And I'm also using this book to teach. It's called the Advanced Engineering Mathematics. Advanced Engineering Mathematics. Name of publisher is Palgrave Macmillan. Palgrave Macmillan. 4th edition. 4th edition means there is 1st edition, 2nd edition, 3rd edition, 4th edition. Recommended is 4th edition. Are we together? So I have taught you in this lecture, I have taught you about the curriculum of Dar es Salaam. It's just the introductions of Tanzania Online Institute of Education. This is the summary of what we have been discussing. In this lecture, Lecture 0, I taught you also about the curriculums of Dar es Salaam Institute of Technology, or curriculums of higher engineering and the scientific mathematics courses, or just engineering courses. And also in this lecture, I've taught you 8 sub-enabling outcomes of engineering mathematics. In this lecture, also I taught you about the 8 topics of engineering mathematics. In this lecture, I also taught you about the integrated method of assessment, the CA, that is weight 60 marks, and at the end of semester examination that weight 40 marks. Okay? Then in this lecture, I taught you about 7 reference books that recommended for you to use efficiently in order to master engineering mathematics, in order to learn, master, and enjoy engineering mathematics for the rest of your life. I believe that it is enough. So, assignment, because remember that assignment is one method recommended for us to teach you. Assignment, tutorials, lectures, and group discussions. So assignment 1. So assignment 1 will be focusing on the first topic that's called the theory of limit. So this is the question. So the question just is, what is formal definition? What is formal definition of the limit of the function? Or define formal definition of the limit of the function. Then second question, write the formula used to find limit of the function, of the single variable function. So dear students, God is saying, Olenjolai, it's now. I would like to say that this is the end of Lecture 0, titled General Introduction of Engineering Mathematics, in the module that's called Engineering Mathematics in departments of Higher Engineering and Scientific Mathematics in our online school institution that's called Tanzania Online Institute of Technology in departments of Higher Engineering and Scientific Mathematics. I would like to say that thank you. I thank God first who have given me this chance. I would like to welcome you into the sequence of lectures in each topic among the 8 topics that I've mentioned in engineering mathematics. The first topic is called Theory of Limit. I would like to welcome you in Lecture 1 of Theory of Limit. I would like to welcome you in Lecture 2 of Theory of Limit. I would like to welcome you in Lecture 3 of Theory of Limit. I would like to welcome you in Lecture 4 of Theory of Limit. I would like to welcome you in sequence of lectures, systematical, up to Lecture 10 of Theory of Limit. So the topic of Theory of Limit, some teachers physically, they used to teach it just in 2 lectures. But we, because we have experience and we are supplementing our teaching with different questions from different perspectives, so that the students once have our own materials and not and understand what we have taught him or her, the students will be well equipped, and there is no any other extra material that the students will be seeking, because we have at least covered everything. So we'll teach you 10 lectures for the theory of limit. In case of Laplace transform, we'll teach you more than 15 lectures. So because Laplace transforms is a little bit long and it has a lot of mathematics work. So please, if it's your first time, welcome other students to learn and enjoy high engineering mathematics anytime, anywhere. And this is the time for you to master it and make sure that you get grade A in continuing assessment and grade A in end of semester examination. If it's your first time, please also register yourself by subscribing to our channel, and also invite other students. This video will be streaming live, and then we'll be looping it so that the message will be sent and distributed to all institutions, universities, and colleges of Tanzania, starting from Dar es Salaam Institute of Technology, and especially from my own departments of Electronics and Telecommunication Engineering, and spreads and be distributed to all other institutions such as Arusha Technical College, such as Mbeya University of Science and Technology, and such as St. Joseph Institute of Engineering, and such as we have different University of Dar es Salaam, University of Dodoma, Karume Institute of Technology and Science in Zanzibar, and different institutions, universities, including Dar es Salaam Maritime Institute or DMI, including also National Transport Institute or NAT in Dar es Salaam, and also including different universities in different parts of Tanzania. So this is the good news. Share with other students, enjoy, invite them, master engineering mathematics. Stay tuned, ask questions as well you can, interact with us, join with our WhatsApp group that's called Tanzania Institute of Technology. And then please just pray for me, pray for my wife, pray for my family, pray for Tanzania Online Institute of Education, Institute of Technology, in square bracket OLENJOLAIM, and pray for all departments and the special departments of high engineering and mathematics. We don't deserve to receive any glory and any praise in this lecture, because it's Jesus Christ who is within me has taught you. So give God all the praise and honor, all the glory that you have experienced, a different touch in this lecture. Let us return and give him all the glory, because he deserves, and I don't deserve to receive any glory. And then let me know, did you understand me? I believe that the answer is yes, and stay connected with me. I will transform you from followers in engineering mathematics to the leaders, to the agent of change, or to the leaders, it means that to the top leaders in engineering mathematics. So before we end this lecture, let us give God thanks, because we had the opening prayer, and this is the closing prayer, so that God will teach us all the 8 topics in a different style, different ways, and different techniques. Let us pray. Our Father who is in heaven, we come before your presence, say thank you for lecture 0, the general introductions of engineering mathematics. I say thank you because you taught me in order to teach your students of first year, second year, or NTA level 7, or any kind of the names of BNG and BSc students. Father, I thank you for this opportunity, and I thank you for the online students. I thank you because you are faithful, and I thank you because you will spread these truths into the entire country of Tanzania, all the 31 regions, and into every institution, college, and university. The good news will be spread to them. Thank you for these students, and keep them, open their minds, and let them to be consistently and serious, our online students, now and forever, during the times of learning and reason. Father, we thank you because you are faithful, and we thank you because you are love and you are forever in Tanzania Online Institute of Technology. Welcome in the next lecture, or welcome to teach us all the 8 topics in a different way. We pray in the name of Jesus Christ. Amen. Amen. Thank you very much. This is the end of lecture 0. Welcome into lecture 1 of each of the topic to the last lecture. Remember to visit the playlist called the Theory of Limit, the playlist called the Laplace Transform, the playlist called the Fourier series in our Tanzania, in our official YouTube channel of Tanzania Online Institute of Technology, where you'll find organized or systematic lectures of theory of limit from the first lecture, lecture number 1, to the lecture number 10. Thank you very much. Invite other students. I'm very happy to have you. I believe that you learned something, and give God all the glory and praise. Thank you very much. You love Tanzania. I am Tanzanians. May God bless you and keep you until we meet next time. Bye-bye.
Your single from beautiful, fantastic, blessed country that United Republic of Tanzania, or in short, just call it Tanzania. It is found in eastern of African continent. So beautiful, even that contains a lot of natural resources. So we welcome even foreigners to come and invest in Tanzania. Welcome. We are very happy to have you today in online undergraduate in Polytechnic Institute of Tanzania. This is online platforms, online institutions. We don't have a physical institution or Polytechnic institutions, but we are delivering all the resources online because of the developments of technology, especially for the internet. So our main transmissions and distributions protocol is internet or media. We transmit the information through the space or through the atmosphere, and the special that by using internet, right? So that the concept that they want you to have in your mind. So I would like to remind you that the vision that we have in this Polytechnic institution or Polytechnic Institute of Tanzania. We have a vision, or that the visions, or that the picture that God has given me when before even establishing, so 4 years establishing this online Polytechnic institutions of Tanzania. Before I established it, God has given me a vision, and the vision is clear, right? It's a picture that's in my mind. I would like to see that, I would like to be a part of teachers who are ready to use their resources, use the talents and gifts that we are being given by God to prepare community of Tanzania, right? Especially those who are ready to take the classroom instructions in mathematics, in computer science or computer programming, in engineering, in science, to solve real life problems in their community, or in their villages, or in towns, or in countries, right? In our beautiful country, in a certain zones, in a certain city, in certain regions, in a certain place, in a certain community, in a certain tribe. So we would like to see the community of students who take the classroom instructions to solve real life problems. That the visions we have in our mind. So how will we achieve that? As I say, that I will be a part of. I can't say that I will be just in, or I'm enough to prepare to that community myself. God has placed a number of people there in order to cooperate together and build something which is productive, right? So then another thing that we would like to remind you, I want to remind you about the problems, first the problem statement that we are solving, and also how are we solving. Well, it happens when I was in my undergraduate studies at the Rest Institute of Technology. Myself, my colleagues, and even my students that have been teaching them after my graduation, during my studies and even after my graduations, we were suffering a lot. We were suffering in understanding modules of higher engineering and scientific mathematics. So to myself, I thank God that it wasn't a great challenge, but to my colleagues, it was a great challenge. And it has been caused by many factors. First of all, you find that some of the students, they are employed, so they don't get enough time on problem solving, etc., etc. But also other causes has been caused by the module teachers, sometimes that they are not consistent on teaching, or even sometimes that they used to make assumption that every student is competent, he still remember about mathematics and so forth. So there are many causes. We are not dealing with the causes, we are dealing with the solutions of the problem. How are we going to solve? Good questions. So these problems we'll be solving by using, I'll be taking I know the contents first of calculus, of all the modules in calculus, for example, that of undergraduate in basic and in higher scientific engineering mathematics. I know those modules. I used to sit down in the presence of the Lord in order to prepare and break those complex ideas and make them simpler and simpler and simpler, so that intermediate student, it means an intermediate learner student, slow learner student, it means that just moderate learner students, whatever, and even faster learner students, they can take the stuff, or they can take those concepts equally, and all the groups will understand what they have to cover in order for them to do the year level PhD. But against that, we'll be using different teaching aids, different teaching methods, different teaching techniques, different teaching methodologies. We'll be using different teaching approach on teaching basic, higher engineering and scientific mathematics. So it doesn't mean that we are competent on teaching this for undergraduate studies, but it means that this is the one of the prerequisite of fundamental courses in all the levels, especially for the first year, second year, and third year for those institutions that offering 4 years educations, and for some of the institutions actually that they used to learn for the first year and second year. Minimum, it means at least 4 semesters. So in these channels, we are teaching students under two according. So we say that in online undergraduate Polytechnic Institute of Tanzania, we are teaching undergraduate students worldwide. Every undergraduate students can benefit on the materials that we offer them, because higher engineering and scientific mathematics is common worldwide. So this material might be useful in any country, or by any undergraduate students studying in any country in Africa, any country in South America, any country in North America, any country in Asia, any country in Europe, any country in Australia, right? So, however, that our main focus will be by using the curriculums of United Republic of Tanzania. It doesn't mean that that's what we know, but we want to narrow our content so that they will be focused to the certain community of the student, right? So in United Republic of Tanzania, we have two authorities. We have TCU and NACTE. So the formality of the modules or courses of NACTE is a little bit different from TCU, right? So however, that also even in case of NACTE, different institutions or colleges, they names modules in different ways, as I explained in lecture 00 of general introductions of calculus. That should not confuse you. For example, that these modules of calculus that we are teaching, we are using the curriculums of NACTE, right? So any institution that is under NACTE, it means that this material will be 100% perfect for them. right? So we'll be using Dar es Salaam Institute of Technology as a reference. The name of the modules in your institution might be a little bit different. Calculus, some they call it calculus, they call it engineering mathematics 1, they call it just like engineering mathematics 2, they call it multivariable calculus, several variables. So regardless of the names, the issue is just the content, focus on the contents, right? So in case that you want too much detail, so we say that in this, we are teaching almost we are teaching 12 modules in this online undergraduate polytechnic, and we're using 3 reference universities, 2 reference universities and 1 institution, higher learning institution. The first year higher level institution will be using as a reference is Dar es Salaam Institute of Technology, and the first university that will be using as a referential on the 4 modules is Dar es Salaam University of Dar es Salaam, or UDSM, and also 4 modules will be teaching by use the reference of University of Dodoma. So 4 modules will be teaching by use the reference of University of Dodoma, means for the first year undergraduate students and second undergraduate students. 4 courses also will be using the curriculums of Dar es Salaam, University of Dar es Salaam for the first year and second year, engineering and scientific courses, non-majors they call it. And then 4 modules will be using the curriculums of Dar es Salaam Institute of Technology, just for the first year and second year, 2 semesters. So in total makes 12 modules or 12 courses. So believe me, in those 12 courses, when we'll be covering or I'll be teaching all of them, you will be competent in mathematics. That's the promise that I want to give you. Okay, so that's all. And then in case that you want to know how you can register yourself or join onto this online platform, make sure that you watch this lecture 00. I've provided many instructions on how you can just register yourself or you can get connected. But just to give you a quick review, make sure that you have your email, whether Google email, Miss Gmail or Yahoo, and that's number 1. Number 2, make sure you subscribe onto our YouTube channels that's called the Online Undergraduate Poly Institute of Tanzania. These are abbreviations of Polytechnic Institute. So Poly is Poly, abbreviation of Polytechnic, Institute, abbreviation of Institute, right? So OLENJOLAIM, make sure you subscribe, and also you make sure that you click the bell, the bell icons that appear, and choose all. Then thirdly, we ask you that to share these contents with your colleagues, because these contents are worldwide, so anywhere they can be accessible anywhere and at any time where the internet connections is available. Again, we ask you to read the descriptions so you can get more information. Even in descriptions, we invite you as the students, as the viewer, as the mathematicians, as the hobbyist, as the teacher, as the lecturer, as the professor, as tutorial assistants, regardless of your positions. You can offer God the thanksgiving for what He has given you through His contents. And then the thanksgiving number that you can use there on accounts. You can go to the descriptions by clicking the show more buttons. And then afterwards, you can use I can send on the accounts, or you can use the mobile transaction by using this number 0759745331 or +255759759745331. And then your thanksgiving will be received with much thanks, and believe me that it will perform and to make sure that it will be a part of running cost for this program, so that many lectures of engineering and scientific mathematics for undergraduate will be in air for the present and future generation. Today, let us go to the first of all. We mentioned also contents of calculus, and then we say that in calculus we are going to learn 7 chapters or 7 topics. The first 2 topics is called the theory of limits, which I'm going to teach you today. And then the second one is called the Laplace transform. The third one is called the inverse of Laplace transform. The fourth one is called the applications of Laplace transform. The fifth one is called the Fourier series. And then the sixth one is called complex or exponential Fourier series. The seventh one is called the functions of several variables. So you have 7 chapters or 7 topics in this module, and we're gonna cover them perpendicularly. And we're gonna solve many examples, more than yes, I believe more than 100 examples in the entire module so that you'll be competent enough. But even yourself, you have to make sure that you do the homework that I'm going to leave for you. So then, let me mention contents now. Contents. I call it the contents or concepts. Okay, concepts. That's we're going to learn in this chapter 1 of 40, theory of limit. Or in short, in some of the institutions or some of the books, they just call it the limit. So what are the contents or concepts now according to the course outline, right? Remember that I told you I use Dar es Salaam Institute of Technology as a reference institutions and an active and a national technical education. But these materials will be useful in Arusha Technical, be useful in Karume Institute of Science and Technology, will be useful at Al Maktoum, okay, at Maktoum, at St. Joseph College of Engineering and Science, and College of Engineering and Science. So these stuff are useful in any engineering and the scientific institution, Bayer, University of Science and Technology. So these materials are useful, right? So contents or concepts of theory of limit. So we're going to cover almost 10 concepts. The first concept which I'm going to teach you today is called the introduction, right? Introduction of limit. This is the business of today. Introduction of limit. The second content that I'm going to teach you today is about informal definition. Informal definition of limit. Formal definition of limit. Then the third concept, we'll teach about applications of informal definition. So informal definition of limit, or just the introductions of limits, what the meanings of limits and definition of limit, right? There are two definitions of limit. Applications of what? Informal definition. This will be lecture 2. Formal definition will be lecture 2. Okay? Lecture 2 and lecture 3. So 1.4, we're gonna cover about rules. Teach about rules of what? Rules of limit of a function. Rules of limit of a function. Okay, of a function. Then 1.5, we're gonna cover about limit at infinity. At infinity, just I called 1 because it's chapter 1. Limit of a function at infinity. Right? And then number 16, we're gonna teach you about the formal definition of limit. We've talked about informal, formal definition of limit. So this is the direction. This is according to the course outline. Formal definition of what? Of limit. Right? Formal definition of limit. Should have your manual, your class manual of calculus. Right? Formal definition of limit. And then the next part, finding the delta. Finding delta algebraical. Right? So algebraically for given epsilon. For given epsilon. Just write like this one. I'm gonna tell you what it means for given epsilon. And then 1.8, I used to teach this model physically for 5 years. 5 years. So if I record this video, so continuity, so I know what am I saying. But remember that Olenjolai does not know everything. Discontinuity does not know discontinuity, right? Does not know everything about calculus. I just know small portions, but I'm ready to teach that small portion. Continuity and the discontinuity, right? Continuity and discontinuity of what? continuity and discontinuity of a function continuity and discontinuity of a function at a point, because you have two parts at the point, and also you have 1.9. I'm going to teach you about 30. I'm going to teach you about continuity and discontinuity. Say continuity and discontinuity, discontinuity, right? Discontinuity, continuity and discontinuity of a function, because you should specify of what of a function, right? And then this one, you say that about 30. About an interval, or on an interval. On an interval. On an interval. On an interval. Right? On an interval. And then, number 10, I will be teaching you how you can solve problems. Problem solving, which in other institutions they used to have tutorial sheet, but in most of the institutions they don't have tutorial system, so or tutors. So you teach concepts and questions together. So problem solving of theory of limit. However, that theory of limit. Okay? So this is the picture at where we are heading. However, that the problem solving, we may do it in every part. So the first one, introductions of limit, I will teach you today. Informal definition of limit. Okay? Possibly I might touch it today. Applications of informal definition of limit. Right? Informal definition of limit, and also rules of limits. I will teach you about rules of limits of a function. Then I will teach about limits at infinity. I will teach about formal definitions of limit. I will teach about finding delta algebraically for a given epsilon. And I will teach about continuity and discontinuity, okay, of a function at a point. And I will teach about continuity and discontinuity of a function on an interval. And I will teach about problem solving of theory of limit, right? So, listen, in physical classes, even myself, when I've been taught this problem or this course in 2015, right? Almost 7 years ago, right? So when I've been taught this topic, the lecturer spent only 2 sessions, it means 2 periods to finish it. So when it comes to the concept of theory of limit, it's not a long topic in terms of concept, but if you begin to solve problems, to solve questions, then you realize that many concepts of theory of limits are hidden in questions more than concepts. So for myself, I'm going to solve almost more than 25 questions in this topic. So I might be spending many sessions or many lecture hours. I might be even maybe spending I may be spending much time on solving different problems. But remember that it's a complete package. What am I going to give you? It's a collections of all the reference material I told you in lecture 00. So that don't get confused on what and how you'll be taught this topic in your physical classes. Don't get confused about that, right? Just release, be free in your mind, and then enjoy the beauty of engineering and scientific mathematics. Okay? However, that this is a supplement. Don't ignore to go to class because of this program. Don't dishonor your teacher because of disrespect. It means that, yes, dishonor your teacher because of this program. No. Honor your teacher, attend the sessions, and then take this as a supplement stuff. Okay? So have a good discipline during your learning period, right? Because I did also the same. I knew this is stuff. I knew this is stuff before even I went to the physical classes. I understood them in advance, but I was going to classes and asking questions and even learning some of the concepts that I failed to understand when I was doing my private study in prior to the module master, or the periods of the sessions at the module master. So now let us go to the first topic or first contents. We call them contents or concepts or subtopics. So regardless of how you call it, you can call them subtopic, right? So regardless of how you call it. So let us go to 1.1. I'll be trying my level best to remember that, and I'll let you that where are we right now. So introduction of theory of limit. Right? Theory of limit. The prerequisite of this module, I haven't told you, the prerequisite of this topic of theory of limit is calculus. But not too much details on calculus. Calculus and kind of geometry, little bit about geometry. That's all. That's what you want in this topic. I will remind you quickly, but in case you forgot the concepts of calculus, also we have a channel that we are teaching calculus, which is called TANZANIA. We have an online school that we call TANZANIA Online Advanced Secondary School. So we are teaching in detail, so you can go there to make your revision. Okay? So introductions of theory of limit. Before even we define what the meaning of limit, I think that we should begin from that point. Have to begin from the point of definition, right? So listen, we have to understand two things here. We have definition. We have mathematical definitions of yes. So he said that in let us begin with definition of 40. So he said that general definition of limit. General definition of 40 of limit. And then we'll go to the formal and informal definitions of limit. Okay? Of limit. So this is the fundamental question that we have in our mind. Pause the video, ask yourself this question. What is limit? What is limit? We want to study theory of limit. What is limit? Pause the video a second, think a little bit. We have a definition of limit in general, right? But this is, we want to define limiting, the definition of limiting in maths or in mathematics. What is limit in mathematics? That's the question that we have. Okay? I found two definitions for you. Three definitions for you. So, you can define limit in general, not even mathematical definition, right? As limit is the point, right? Limit is the point or value. So a limit is the point or value. It's either point or what? Or value. Limit is the point or value. So this is the point or value, right? So limit the point or value which a sequence, say sequence. You know sequence, remember that you learned during your Form 3, sequence and series, and even during your Form 5, okay? Which a sequence or a function, can be a sequence or a function, right? Or a function, or it's not a sequence, it's not a function, or what? Sum of a series, or sum of a series. So these are mathematical items that contains limit, right? Or sum of a series can be can be made, okay, can be made to approach progressively. To approach progressively, right? Progressively, okay, until they are close to it as desired. Until they are close to it, they are close to it as desired. Till they are close to each as desired. Do you enjoy the beauty of mathematics? Possibly you might say no, because you didn't see what is troubling your mind. Don't worry, we're gonna get there soon. Until it is what it is to eat as desired. So this is the first general definitions of limit, not mathematical definitions of limit. We have informal mathematical definitions of limit and the formal mathematical definition of limit. This is general. So let me explain in brief before I give you the other one, right? Before I give you the second definition. So we say that limit is a point. First of all, limit is not something else that you might think that maybe it's a question, so it's a function, or it's a formula. No, limit is a point or a value. Certain point or a value, right? Which a sequence, number one, or a function, number two, or sum of series, not only series, sum of series. Okay, so it means that a sequence, this is just explanations, can be made to approach something called a limit, or a function can be made to approach something called a limit, or sum of series, which we write maybe, for example, as sigma notation, approaches to a limit. So that's what you call the approaches to a limit, can be made to approach progressively, right? To approach mean that to approach, to be closely to it, but not equal to it, progressively, until they are close to it as desired. So the end of approaching is until they are close to it as desired. Okay, so that is one of the definition. I will give you examples. Don't worry about understanding. Fundamental plan in this program is we have to make students, they restore their love in mathematics and they understand more than how they expected. So he said that, oh, in mathematics, limit, okay, so that is general. Limit is a function, right? Limit is a function. The value, not is a function, excuse me, as we say is a value. A value, so this is the value toward, so limit is a value toward which an expression converges right? Converges as one or more variable. As one or more variables. Converge as one or more variables. Approach certain value. Approach certain values. Okay, approach certain values. Yes, approach certain values. So So let me explain. In mathematics, limit is a value. Two words. With an expression, this is an expression, for example, algebraic expressions or whatever, converge. So we have something that we call to converge, not diverge. Diverge is just like moving away. Converge means like collecting, right? It means approaching. So this is diverge. This is converge, right? Converge as one or more variables, right? Approach what? Certain values. So what does it mean? So convergence demanding on two things moving from left to right and then from right to left. So they approach to it. So this is what we call a limit. So that's why that in case of the limit, we have a term that we call approaches to. Okay? So this is the certainty values. So that's one of the definition. But again, I want to give you the set general definition because I want you to understand what are we studying. Right? What are we studying? Or we can say that limit okay, you can say that limit second definition, you can say that limit enjoy the beauty of mathematics, my beloved student. So you can say that limit as limit or we say that this is according to Wikipedia, say that or in mathematics a limit is a value that a function, so here we specify approaches, because in calculus we are dealing with functions. Okay, approaches, right? Approaches are the input, right? At the input, I will show you what the input. At the input approaches some value. The input approaches some value. As input approaches some value. So you say that in mathematics a limit is a value that a function approaches at the input approaches some values. That is the definition. So you say this is the value. Maybe 2, it may be a half, maybe 0.5, but it's a real number. It may be a certain later. Okay, is a value that a function approaches. So we'll be seeing some function as input at the input approaches to some values. So we say that we have an input and output. So a limit is an output of a function. An input, it means that is what we say that as we approach. So an input is the one that converge. So when an input is converged means that we approach the input from left and right, then we get the output, which is y in terms of the function, because the function of y and the x. So x is an input in most cases, and y is what is an output. Okay? So that's the piece of information. So another question that, why do we study limits? That's the questions that we have now, mind. Okay? So this is the question, just a brief question. Why do we study limit? Why should we study limit in engineering? That's the homework that you should think. Why should we study limits in engineering? Why should not pure mathematicians study on a limit? Why we engineers and scientists we need to know the concept of limit? So it's a limits are essential. So limits are essential to calculus concepts of limit is very essential, very important means to calculus and mathematical analysis. And mathematical analysis. Mathematical analysis. And I used to define continuity, and I used to define continuity. Why do we need? So we want the concepts of continuity in engineering, right? We also used to define the concepts of derivatives. It means about differentiation. So we need differentiation in engineering. And what intervals. So we mean about integrations. So this is one of the reasons. So limits are essential to calculus and mathematical analysis. Analysis are the one branch of mathematics. Why? Because we use this limit to define continuity, derivatives, and intervals. Right? So because we are using derivatives, we are using continuity, we use intervals, then we need to define this concept of limit. However, that in this topic of theory of limit, we'll be focusing on on continuity, right? So that is all about general definitions of limit, right? Just to give you an example before even I move forward. Example of function that including limit is in case you have limit x approaches to 4 and then you have x squared minus 4x possibly that over x cubic. So that is example of the limit, or the question that as x approaches, so this is input, this is output. So the response that you get there to be a limit. So against might be that, let's say x approaches to a half, and then you find that you have x squared plus 4x minus 3 over x. So those are the examples. So for instance, that you can find that the limit in terms of limits itself, so that as limit as x approaches to 3, and then here we have 3x minus 9. The answer is 0. So this is the limit, and this is the input. So this is the function which you can find its limit. This is the function you can find its limit, but as x approaches to 4, here as x approaches to what? To a half. Right? So what you say limit, for example, let me give you the last example. Say that as limit as x approaches to 3 or approaches to 1, then here we have x squared minus 1, right? Or x squared minus 5. So the answer is equal to -4. Or for instance, that x squared plus what? Plus 1. So if you find the limits for this case, I will teach you how we can find. Is 6. Right? So this is the limit, is 6, and this is the output. So 6 is input, output, this is an input. I will show you how we get those concepts. In case you have any questions, don't hesitate ask in the comment section. I'll try my level best to help you to understand, but make sure that you work hard. Okay, so those are the examples of general definitions of limit. Then now let us go to the mathematical definition definition of a limit of the function. A limit of 40 of a function. So mathematical definitions of a limit of a function. What do we want to teach you here? First of all, we want to give you information, very important information. There are two types of 40 of mathematical, or there are two mathematical definitions of 40 of limit, right? So let me mention them. The first one, call it informal. Informal definition of limit. Explain to you what does it mean. Second one, we call it informal definition of limit. Formal definition of 40 of limit. So you have just two definitions of 40 of limit. The first one is informal definition of limit. The second one is called the formal definition of limit. These are mathematical. So instead of mathematical, we can define them and give them the formula. The previous definition of limit, it can't give us formula. Okay, so this is the technique, or one of the teaching aids or technique that the Lord has given us. Whenever we are teaching you some of the higher engineering and scientific mathematics, we also have to recall what you know in advance. That's so we can build our foundations of higher engineering and scientific mathematics on top of what you know, right? So you say that you want to define, first of all, that you want to define this informal definition. Informal definition. But the way that you can define this informal definition for an ordinary student is a little bit complex. It's better if we do geometrical representation and then come and define it. We say that the limit of function a limit of function, as Atlas approaches to that, can be defined geometrically. Can be defined geometrically. Be defined what? Geometrically. How we can define it geometrically? So let us start with prerequisite. Prerequisite of what you know about, or some of the mathematical concepts that you have that can assist you or help you to understand the theory of limit. So let us begin with some equality inequalities. Okay, let's say geometrical. So this is just like a quick review. So let's say geometrical representation of a function, let's say. Not a function, let's say, yeah, geometrical representation of numbers, let's say. So I will start with positive number. So let us consider figure 1 below. Right? This is suppose this XY axis. Listen carefully, follow me along. I'm doing the quick review prerequisite. Possibly you've forgotten this concept. Right? In many institutions, they just used to go straight for it and give you the formula of informal definition, which is not right, because it's a little bit difficult for you to understand how did you do a shifting. Suppose that you can have, let's say, that a certain function that maybe it has been drawn here in this shape. So this is the certain function that we call f of x. Listen carefully. Then we want to know the value. So this is y-axis and this is x-axis. Okay? Suppose that this is 2. Listen carefully. So because that is number 2, listen carefully. And then we say that you agree with me that all of the numbers before 2 on the left hand side, these we call them are the numbers, suppose that this is x, which are less than 2. Right? Listen carefully. And then this side, in mathematics, we can call it left hand side. Again, the numbers are on right hand side of this line, we call them, these are x greater than 2. Right? And then we say that this is x, we say that this is right hand side of x is equal to 2. So listen carefully. So because that the numbers on left hand side of x is equal to 2 are less than 2, in mathematics we use this symbol. Listen carefully. We just say that x, as x approaches to what the number here is 2, right? Then you use this negative bar to indicate that as x so we say as x approaches to 2, this is number 2. Right? As x approaches to 2. Okay? So as x approaches to 2. So that is, so when x approaches to 2, in mathematics we used to say that as x approaches to 2 bar. So that means that left hand side of x is equal to 2. Then we got the right hand side, x is greater than 2. How do you write mathematics? So you can predict it. This image we write as x approaches to 2 positive bar. Many teachers, they fail to understand from what you know. So whenever you see as x approaches to 2 positive bar, it means that the right hand side of what? Of a number, right, of 2. And then so whenever you see that as x approaches to 2 bar, right, then that is left hand side of what? Of a number. Don't get confused. Right? If you didn't understand, repeat that video several times so that you understand. Because what am I doing? The point that I want to make is I want to show you where do you get these symbols. X approaches to 2 bar, x approaches to 2 positive bar. Where do you get them in mathematics? That's what I want to show you. Just so this was figure 1. 1.1. Okay? Then we want to go for part B. Again, we need to draw another geometrical representation. Okay? Suppose that this is our XY plane. And this is our x-axis. This is the y-axis. Right? So this is x-axis and that is y-axis. Suppose today we have another number which is -2, but on left hand side this is 0. So this is our line. When we divide or we define our limit of the function, we used to say that an input should approach 2 but should not equal to 2. Just like this. Right? So you say our number today, our input is -2. So it begins with this side. This side, believe me that regardless that this is negative number, but you agree with me that on the left hand side of this straight line, so on this side we say that x is less than -2. Do you agree? Remember you are O-level algebra or ordinary diploma algebra. Do you agree? Okay, good. So if you agree, that is true. And then so on this side we say that x is greater than -2. Do you agree? Accept that x is equal to -2. Okay. We believe that on left hand side of this line it is what left hand side, and on this side it is what right hand side. Okay? So we want to discuss the limit of the certain function as x approaches -2. How do we interpret it in mathematics? Well, so this as x approaches -2, it's left hand side, so we say that this is as x approaches to -2. Okay, approaches to -2. But now because left hand side we have negative bar. Okay? Do you understand what are we talking? What are we discussing? These are still simple concepts, but you want to get to the entire picture. And then so you come on this side. So this side you say x is greater than -2. So that's right hand side. So it will be x approaches to -2 but positive bar. Right? Positive what? Positive bar. Right? That is. So for instance, again, on the same diagram, let us use another number, let's say T3. So simple to know that what do we mean about this. So for instance, here you agree with me that all the numbers on left hand side of this line are less than 3. Right? And then we agree that all the numbers on this side are greater than what? 3. Right? This is normal inequality. Our number is 3. Okay? So then, this one we call it left hand side. And this is what we call the right hand side. Right? And here we are. Okay, so because x less than 3, it's on left hand side, we use this symbol to show it. As x approaches to 3 bar. Right? Okay, because soon we're going to use letters. Then here we are. So it means that now, if that's the case, x is greater than 3. So in ordinary diploma, we write just like this one. That x approaches to what? 3. Okay? So as x approaches to 3, but this is positive. So I told you that this positive sign, 3 bar of positive, 3 bar of negative. That means what? Those are the numbers less than . Okay. So this is the general concept that you should bear in your mind. So I've used the we call them integers or counting numbers or whole numbers or yes, count numbers or whole numbers. See, once again to build on top of that, and have a geometric representation now. Okay, so this is y-axis, this is x-axis, right? This is origin. Listen carefully. Suppose that we have a certain function. F(x). Okay? Suppose that here we have a certain letter. And let's say x is equal to 4, but we don't want to mention it. So what are we going to do? Algebra gives us permissions to let that is a. Right? It's a. So it's a. You can get its value. Right? Get its value. So suppose that is a. So this is the value of 40 of a. Okay, that's a. So it means that all the integers and even non-integers on left hand side, these are x less than a. Right? X less than a. And here we are. All the numbers that are used to be behind of the number, then it is what? Here we say that this is x greater than r. By using latest number instead of using number. First example I used number, second example I used dot as a position, right? So it means that this x less than a, we write that x approaches to no. So you say that yes, x approaches to a. So for this one, as I said, that x approaches to a, and because it's left hand side of a, then you have negative. Right? Then you have what x as approach to positive a. Right? So x approached, and then now we used to 40 bar of positive. Okay, so from here, now we can define the definitions of the formal definition of limit. Because you have piece of information about the limits, and then we can have even a simple description of the function. And I'll explain it to you in detail in the near future. Okay, so these are the definitions. X approaches to a bar, X approaches to positive bar. That is. So listen carefully now. Okay. Again, another part of prerequisite, we say that this is the we call concept of what? So let us recall the concepts of 40. First, the principle. First, the principle in calculus. Recall the concepts of 40. First, the principle in calculus. Say first, the principle. So the principle we use to learn that f of x dash x dash, this is equal to limit as x approaches to what? For distance to a. For there it was as x approaches to changing x, and then there we have what? Then we say that there we have f of x, that's small change in x, and that's f of x. Okay, divided by what? So this one divided by small change in x. When we let it the small change to be x, we say f of x dash. For example, if we let changing x is equal to h. So say f of x dash limit as x approaches to h for instance. Then we have f of x as h minus f of x. And divided by what? By h. So this is the common principle that during your Form 5 you learn TT in calculus. Also, if you have been doing basic applied mathematics, you learned about that. Also during your ATA level 5, and you learn also about that, first principle in differentiation. As x approaches to it, as x approaches to h. So this is the way that we use to write what? Derivative of a function itself, which is like a formula, limit. This is the way that we are writing the limit, or you write the limit, right? So it means that the way that you can write the limits of the function, we say that now, limit of the function, this is the very confusing part, is equal to what? So limit of the function for instance, right? We say that for instance, we have limit as x approaches to 3x plus 4y, okay, maybe plus 1 plus x cubic over 4. So you see the way that you write. So this is the function, this is the limit, this is the value. So you say that generally, limit is written as limit as x approaches to a, as x approaches to a, and then here we used to have f of x. This is equal to r. I'm just writing the format of writing the limit. This is input and this is output. So this is the function. So this is the general form of writing out, whether for negative integer or positive integers or fractions, of writing limit. Right? So then I believe that up to this moment we've understood. So I can give you the formal definition of what? Of limit. Because you have to remember this first principle. So even if you do remember that, you just find, let's say, ff2 as x is equal to x cubed, x equal 4. Right? So then we say that, okay, fine. So x minus what? X power 4. Excuse me. For instance, that you want to differentiate the function, certain function here, which is as x is equal to x squared, as in first principle. So you used to write that as limit, first with that x maybe approaches to h, then you say that instead of x squared, let me give you just a simple example. For instance, you'll be given a function f of x is equal to x squared. And then use first principle to what? To find what? Find the x of x squared. So for instance, I use the first principle, right? So we say that for this case, limit as x approaches to h, and then have f of x plus h. So this x plus h, and this one is squared, right? And then we say that minus what? F of x, which is x squared, of what? Of h. Right? So you state that, just I want to remind you, because we want to repeat this stuff once again. Approaches to h, right? So this one will be x squared plus 2xh plus h squared minus x squared, for instance, over h. So this is the point where you have noticed the concept of limit, but the issue is you are not using the value of limit. We've been using it less, right? So then we say that this one, we say limit as x approaches to h, right? And then this is makes what? So x squared minus x squared to 0. So this is twice xh plus h squared over h. Right? Good. Why? Because x squared minus x squared has been ended. So you can simplify now. The 1h by 1h. Then you see, say the limit as x approaches to h. So this is what? Twice x. Twice x plus what? Plus h. So you used to take the value of x, which is h, and substitute there. So you see that 2x plus what? 0. So the answer is 2 what? Twice x. So this is how we have been using limit in calculus. When we learned it in the subject called basic applied mathematics, or when we learned it in advanced mathematics, or when we learned it in ourselves, or when we learned it in ordinary diploma. So that's what we've been doing, right? That's why I said that the general formula is just like this one. So now I'm ready to bring to you a literal definitions of limit, right? So say that informal definition of limit. So we say that if f(x) is defined for all x near, right, near to A, excepting at x is equal to A. And if we can ensure, that f(x), right, f(x) is as close as we want to L as x approaches. Just write this definition, then I'll explain to you what does it mean. Approaches A, but not what? But not, okay, but not equal to A. Equal to A, which means that x is not equal to A, right? Then f(x) approaches to L. This is infinite definition to limit, and this limit is L. Say as x approaches to A. Let us just end there and explain, give you brief descriptions, and you enjoy. Keep on enjoying. So now we are speaking mathematically now, because we began to speak in terms of the functions or formulas. Okay, so let me explain these informal definitions now. The general definitions of informal. It's beginning with the set. If f(x) is defined for all, so it's defined for all x, so it means that is because this f(x) is the function that we say that f(x) is the function of x, right? So this is y is equal to a certain functions of x, right, for all x near to A, except at x is equal to A. That's the first condition for informal definition. And if we can ensure that f(x) is close as we want, so this f(x) y is close as we want to limit as x approaches to A, but not equal to A, then f(x) approaches to limit. That's all. So listen carefully. We say the general formula of writing a limit, you say that is this one. So listen carefully. This is equal to R. This is what we call informal definition. I repeat, let me explain this first. If f(x) is defined for all x, so this f(x) is a certain function. It can be a rational function, it can be a linear function, it can be quadratic function, it can be cubic functions, so any polynomial function, right? And then we say that it's defined for all x near to A. So near to A. So this is a certain number, fixed value, near to A. Okay? Except at x is equal to A. Except at x is equal to A. And if we can ensure that f(x) is closer, so if we can ensure that f(x), this function, is closer as we want it to L. L stands for the limit. As x approaches to a but not equal to a, okay, then f of x approaches to what? To limit. What does it mean? We say that a limit of a function we can find when x approaches to a. Then you have the limit of the function. That's the simple descriptions. Before even just I explain to you in details, or I can give you even the other definitions. Don't worry about that. What do we mean, first of all, right? We say that, so you can choose it, that is definition of the other one. We say, listen carefully. As x approaches to a, but x is not equal to a, right? Simply, we say that f of x is equal to limit. That's all. What does it mean? Geometrically. Geometrically, can present informal definition. Listen carefully. This is y-axis, this is x-axis, right? So you have y-axis, and this is x-axis. So this is origin. Suppose that this is A. Listen carefully. This is A. So because this is A, we say that if you draw the dotted line now, remember that what I told you, on this side we have values of x, or numbers which are less than a, and then this side we can call the left hand side of a, right? And I told you that this in mathematics we just write now accurately as x approaches to a bar, means that values of x from left hand side towards a, and then at this point here, only at this point, only at one point, right? Only at one point, x is equal to a. So x is equal to a. Again, we have another part of that value of x, value of y is this side. So on this side, we say x is greater than a. And also, this one we go to right hand side of a. And mathematically say that x approaches to a but positive. Positive. Right? So, what do we say? We say limit will be defined as the value of y when we approach a from left hand side towards a, and when also we approach a from right hand side toward a, but not at x is equal to a. That will be called the limit of the function. Let me repeat. A limit of a function is a value of the function when x approaches to a from left hand side, right? And when x approaches to a from right hand side, but not at x is equal to a. That's the meaning. So if f of x is defined for all values near to a, except that x is equal to a, and if we can ensure that f of x is close as we want to L, right? As x approaches to a. So as we approach a from left towards a, and also as we approach a from right side towards a, if we'll get the same value, that same value is what we call the limit. But not at x is equal to a. So the only unwanted point is x is equal to a. But we have two wanted points. Okay, two wanted sides. So we have left hand side and right hand side. That's what we want to determine the limit of the function. Don't worry, I'm here to make sure that I simplify this concept. Believe me that this is kind of the hard concepts we are beginning with in sort of limits to understand it. I remember because I taught more than 2,000 students physically this concept. So I know how they have been getting troubles to understand it. Right? So before that, this began with informal definitions of the formula. Listen carefully. in order to have informal definition of the formula, let me repeat, right, with another numerical representation, just like this one, right? This is origin. So this is y-axis, and this is x-axis. Suppose that this is A. Listen carefully. We have two sides. Left-hand side, which is x less than A, this is equal to left-hand side, right? And then we want to find, we have maybe a certain function, right? We have a certain function, right? So this certain function, our aim, we want to find the limit or the value of y, because limit is the value of y. So this is what we want to find, the value of y, limit, right? And then we say that, let me just use a large geometrical representation so you can see. Limit is nothing but very interesting concepts of function. Let me help you. This is y-axis, this is x-axis, this is origin. So this is y-axis, this is x-axis, right? Suppose that we have this function y is equal to f of x, and then suppose that here we have a, and then start, we want to deal with it. Suppose that we have a straight line that begins with a simple function like this. So this one we use called a, but let us call it L. L means limit. It's the value of y, right? So you have to, they have two sides of a. We have left-hand side, which is x less than a. This we call the left-hand side, right? And then you have right-hand side, which is x greater than a. This we call the right-hand side, right? And this one, I told you in mathematics, we are writing that as x approaches to a bar, this is not negative, it is bar, to indicate that we are approaching a from left-hand side toward the a, but we don't reach at the point when x is equal to a. Only one point. And then so this one, we write that as x approaches to a, positive, to indicate that we are approaching a from right-hand side towards a, where the values of x are greater than a. The values of x on this are less than a, and the values of x here are greater than a. That's the meanings of this bar and this positive sign, right? That's the meanings, because we're gonna use these symbols soon. So how do we define we define this limit of the value? So L will be defined, means that we need only two conditions. The first condition, just one condition. We say that the conditions for L to exist. However, that will teach us application, right? Condition of L to exist, limit to exist is this. The limit of left-hand side should be equal to the limit of right-hand side. What does it mean? The limit as we create the value of y as we approach x towards a, near to a, towards a but not equal to a, should have the same value with the value of the function as we approach x from right-hand side towards a. That's the meaning. So it means that to determine limit or to have informal definition, we just need limit of left-hand side, and then the second condition is limit of right-hand side. That's all. So let me break it down. Seems like you're getting confused. Don't get confused. So we say that the necessary condition for a limit of a function to exist is this. The limit of left-hand side of the input should be equal to the limit of right hand side of the input. Where are the limits of left hand side? The limits of the left hand side, we say that this of left hand side is very important. We write it as limit as x approaches to a bar. This is limit of left hand side, right? So is this one. So as x approaches this one. So of a certain function, certain unknown function, which is f of x, should be, for example, equal to L, right? And also we say that the limit of right hand side also, it means that as we approach A, from right side towards A, this we write like this one, of a certain function, unknown function, but the same function like above should be equal to L. So once the limit of left hand side is equal to the limits of right hand side, hence the limit existed at the value of limit, right? So that's why that we say that now for the limit to exist, we say that the limit as x approaches to a bar of f of x, this should be equal to the limit of right hand side x approaches to a positive, it means values greater than a, here values less than a of a function f of x, and this will be equal to what? Limit. So we say that mathematical informal definition of limit is given as this. We say limit as x, detailed definition, x approaches to a of f of x. This one should be equal to the limit of right hand side. Remember that this is left hand side and this is limit of right hand side. Refer those geometrical figures. This is figure 1.4. Okay? Approaches to a. These are the values of x greater than a of a certain function f of x. This is equal to R. So keep this formula the rest of your life in calculus or in engineering. You're gonna need it. So the general definition now, right? The general informal definition of limit. So this one and this means the limits of left hand side and the limits of right hand side together. We can represent them by using the single formula, which is this: limit as x approaches to a of a function will be equal to R. So this is the general formula. So whenever that we find, let's say for instance, we find that limit as x approaches to 2 of x squared plus 4 over, let's say, 3x plus 4 is equal to 3. This means that the limit of this rational function x squared plus 4 over 3x plus 4, as we approach 2 from left hand side, is equal to the limits of x squared plus 4 over 3x plus 4 as we approach 2 from right hand side towards 2. So here we have to find two limits: limit of left hand side and limit of right hand side. If they are equal, then we have a limit which is equal to what? To 3. That means. So it means whenever we write this definition, this is the general, which is combining definitions. We have to translate that the limit of left hand side as x approaches to a bar is equal to the limits of right hand side in which x is approaches to a positive bar. And that's why that we have L. So remember also here I present the limits of left-hand side, right? So these are also important formulas. Right? So these are the important formulas also. You have to keep them. Also, this is another important formula. This will give you limit of 40. Right hand side of the function, or right hand side of the input, like this. So remember, limiting is nothing. L is nothing. It's just the f of x or y, which has been conditioned. That we say that this is provided that, so you have to write here, provided that x is not equal to a, but we are just to approach a, but x is not equal to what? To a. So even this one is provided as long as we say x is not equal to what? To a. So this is a informal definitions of limit. We're going to use this formula in next lectures effectively. So you have to be it, you have to understand. In case you have any questions in the comments, I've tried my level best. I'm not sure if there's any teacher who will teach you the concepts of limiting this formality or this style. I'm not sure. Possibly there is, but I spent much time on preparing this lecture and how can I present this new idea in your mind. And it has to stick in your mind so that you enjoy, because always I love my students. They used to tell me that, yeah, now we understood the concepts of limited. It will be difficult to understand, to forget. Okay, so that is the general sentence or general issue. To say that if f of x eventually gets closer and closer to a specific value L as approaches a chosen value a from the right, then we say that the limits of f of x as x approaches a from the right is L. Say that the limits of that one's general definitions. Remember that we say that this is not exact or precise definitions of a limit. The formal definition is more precise, and the exact mathematical definitions, which will be discussed later. So let me end this session with that sentence. Right? So it said that, I think that this I should give you a homework. Okay. So it said that informal, so this is the not. Informal definition is not a precise, say precise, or it's not a precise or accurate definition of limit, but formal definition, formal definition is more precise than informal, right? More precise and accurate. And this one will be discussed later in this topic. We will learn it in this topic. So to summarize, what I wanted to write in your mind, general definition, the contents first, the subtopics of the topic of the theory of limits, the general definitions of limit, and the informal definitions of limit from the geometrical concept that you know, from inequalities concept, from first principle that you know in calculus, and also we came into the desired informal definitions and deduced its formula from the geometrical interpretations of a function, right? I gave you 3 definitions of a limit, so make sure that you go through. Let me leave here homework for you, right? Homework 0&1, okay? And mention 5 applications 40 of limit in engineering. Okay, so this is the end of lecture 1 of theory of limit. I'm very happy. I thank God who have been with me since preparations of this lecture, and I thank God who have given me power to teach you this lecture, and I thank God who have given you an opportunity to be with me. And I'm praying for you. Pray for me also to make sure that I do what I said and I do what God wants me to do before at the appointed time that He wanted me to do. And then I would like to invite you into the next session when I'll be teaching you about applications of informal definitions of limit. So don't miss. Stay connected and stay tuned. We'll be together soon in lecture 2 or 40 of applications of informal definitions. So, and then we'll be solving some problems, and then we'll have another sessions of lecture 3, which will be doing more questions of informal definition. So thank you very much. May God bless you. I appreciate, and I actually thought I'm very happy for your time. I believe that you have got a lot of concepts. In case you have any question concerning about what I've been teaching, ask in the comment sections. In the comment sections, tell us also you're enjoying this material, from which institutions or from which college or from which university, and how helpful are this material in your undergraduate life. Also tell us from which city, which continent, or which country, because we have a plan to reach thousands or 40 of undergraduate students with the beauty of engineering and scientific mathematics. So thank you very much. Let us meet together in the next session. May God bless you.
Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.